Okay, so this is going to involve some live coding. So I'm just crossing my fingers and hoping that everything is going to go well. Ooh, let me see if Teams allows me to share my screen. Okay, so you should be seeing my screen. Can you see it? Wonderful. So right here, I have set up an application, dummy application. What it does is it simply displays a list of transactions. So here I'm pretending that I'm a bank, and I'm just going to display a list of transactions. It's something very simple, very straightforward, and I'm going to just show you how it works in the background in just a few seconds. So here, what I want to share with you today is some of the patterns that I've learned at a prior job. This is something that I had never seen done before, that I found very, very interesting. So the mindset at this company was, we want to build a very reliable experience for our users. We don't want to have any errors ever. We don't want to have runtime errors. We don't want to have unexpected errors. So reliability is key. That is our number one goal. It's to ensure a reliable experience. Things don't break, and customers just trust us as a reliable product. And there were a few patterns and a few mantras that were adopted at this company that really enabled us to do that. And these are some of the patterns that I want to share with you today. So I'm going to start off by showing you the code base, what we have. This is a very simple React application that I set up with Vite. And it just does exactly what you expect it to do. So I have a single app component, which is loading some data, rendering some components. So it is loading a transaction list. Then it is rendering a transaction list component, passes it the transactions. Inside of domains transaction list, we have a transaction item component being rendered, which receives a transaction object. The transaction item component then decides what type of transaction to render, whether that is an inbound transaction or an outbound transaction. If it is an inbound transaction, the inbound transaction item component gets rendered. If it's outbound transaction, the outbound transaction item component gets rendered. Now, I just noticed while we were doing this that there was something here that's unexpected. Okay, so we're going to get to that one. So let's see. Our data is coming from this transactions.json file. It looks like this. Here, I am mocking a REST API by mocking the fetch function and saying that it always returns a promise that resolves with an object containing a JSON method that returns a promise that resolves with this. So it's essentially the same thing as making an API call through the network, but what we get is this. So I just didn't want to set up a server just for this purpose. So this was the easiest solution that I found. The list of transactions is an array containing all of these. You might notice that inbound transactions and outbound transactions look slightly different. The first, inbound transactions have a type set to inbound, while outbound transactions have a type set to outbound. Additionally, outbound transactions have a reason for the transaction. Let's just pretend that when I issued a transaction through this banking application, if I make a payment to someone else, I have to write down the reason for this payment. And when I look at the list of transactions, if I make an outbound payment, I want to be able to read why this payment was made. And so this is why outbound transactions look different from inbound transactions. For now, I went ahead and modeled all of this data as some TypeScript types, something very straightforward. So what I have is, first, I have a money type, which is an object containing an amount and currency, which this transaction value is going to be mapped to. And then we have a transaction common properties type, containing the ID of the transaction, the name, and the value. So these are common properties to every transaction. Then we have two different types of transactions: transaction inbound and transaction outbound. They share the common properties, but inbound transactions have a type inbound, outbound transactions have type outbound, plus a reason. Now, here I'm saying all transactions are either an inbound transaction or an outbound transaction. Then I also created this additional type called transactions plural, which is just an array of transactions. So I hope that all of this is clear. Regarding the directory structure in this project, I chose to create a domains folder inside of my source folder, because this is how the projects were set up at this other company. This was a domain-driven design mentality that was adopted. And so I just tried to replicate it as closely as possible while still keeping it simple. And this is the reasoning behind this. But these might as well just be components inside of a components folder. There is no particular reason why they would be here other than we're attempting to follow this domain-driven design methodology. So let's see a few of the issues that we have here in this application. So my first issue is, with what I have, I cannot ensure feature completeness, quote unquote. What do I mean by this? So right now, our application is working. Everything looks beautiful. But imagine this scenario. Imagine that I create a new type of transaction. This transaction would represent an exchange of my money from euros to dollars or dollars to euros, for example. Let's just play with that hypothetical scenario. How could I model that type of transaction? So I could have, I could have type transaction or exchange transaction. In fact, to keep up with the naming pattern, let's do transaction exchange. It would take all of the common properties of transaction common, but it would have a from property and a to property, both holding money objects. It wouldn't have a value property. So here I could omit value from transaction common, or I could just place the value property in the transaction inbound and transaction outbound, and everything should be fine now. So now I have these three different types of transactions. Let's add this additional type of transactions to our transaction union. So there are these three possible types of transactions. Now, if I go to data, transactions, I want to create a mock exchange transaction. So this mock exchange transaction, in fact, we might want to change something else here. So this mock exchange transaction should have a from and a to. So we're saying from a certain amount of euros to a certain amount of dollars. But by the way, we want to have a discriminator type here, which we did not add when we created our types. This would be exchange. And these also don't get a name. So I need to correct my types here. Here in transaction exchange, I want to have type exchange. And then exchange transactions don't take the name of the person that I'm sending money to. And so I will place name in these types instead of in the common types. So here I'm just trying to simplify things as much as possible. We have these three different types of transactions. I just added this new mock transaction to our list of mock transactions. So you could just think everything's fine, our app should run, let's deploy this, let's push it to production, and the customer would be fine with it. But if I refresh my application right now and I look at my list of existing transactions, I don't see that transaction right here. So I see a transaction from Ankit and a transaction to Mateusz. Let's look again at our data. So my first transaction was to Ankit. This one was to Mateusz, just to ensure we're not having any ID collisions. Let me change the ID for that one. And essentially, we're not seeing this exchange transaction. Why is that happening? So let's look again at our components. We have the transaction list component, which renders a transaction item component. Transaction item is responsible for rendering either inbound transaction item or outbound transaction item, depending on the type of the transaction. But we're missing a case here, as you might have noticed. We're missing transactions of type exchange. We're not doing anything. If a transaction has a type of exchange, we're not rendering anything. In practice, we are returning here false. False is being returned by this component if transaction type is set to exchange. This is not okay because we're missing one essential feature of our application. Essentially, we don't have feature completeness because we missed something, but nothing in our build process broke. We weren't alerted to this lack of completeness. And so what I want to introduce right now is a pattern that would avoid this issue altogether. This pattern that I'm going to introduce would stop me from building my application, from TypeScript compiling my application, if I did not render one different type of transaction for every possible type. So what we want to ensure here is feature completeness. How could I do that here, though? So first, let me talk to you about a TypeScript type called never. You might have heard about never before. What is never? So imagine this scenario. I have a variable called name. I have two names, Jose and João. In fact, no. These would be the types, possible types for name. And I would say that the variable holds Jose. If I have an if-else chain, and in the first if, I check if name equals Jose, and in the second if, I check if name equals João, what is the value of name in the last else, in the if-else chain? What would be this? What is the type for this? The type of name right here is never, because this is not possible. If name is not Jose and name is not João, then the TypeScript compiler knows right here that name is set to never. So we're going to use this never type to ensure that something never occurs in our application. We're essentially going to set a trap inside of our transaction item component. We're going to place this bomb essentially somewhere in our code. And if we try to build our application and we don't consider one particular scenario, this bomb is going to blow up and we're not going to be able to move through. So how do we do that? We do that by writing some exhaustive type checking around the transaction type. How does that work? So instead of just returning here with a conditional, we could do this with an if-else chain. We can also do it with conditionals in practice. But I think the most appropriate solution here would be a switch statement. So we have a few possible cases, as you know. We have the inbound case. If it's inbound, I simply want to render the inbound transaction item component. We have the outbound case. If it's outbound, we have the outbound transaction item component. Now, let's just pretend that we're still forgetting about the last case. I'll set here default null. As you can tell, right now we have exactly the same solution as we did before, but with a switch else or a switch statement. The concern here is there's possibly one additional scenario, which is case is exchanged, that we're not considering. So we're lacking feature completeness here because we're not considering that case. How could we ensure right here that every case is considered? So we could do the following. let's think about what is the type of the transaction variable in this situation here. So if transaction type is not even inbound, and if transaction type is not outbound, then transaction type has to be exchange. So the TypeScript compiler knows that right here, this transaction holds a transaction exchange. How can we leverage the power of never here to ensure that this does not occur? We can do the following. We can create a simple variable, say that it holds transaction, but type that variable as never. What is the issue? The issue is if the TypeScript compiler arrives at this line, and then it knows that transaction has a transaction exchange type while we're typing the variable as never, everything breaks. If we see this, this tells us there is one case we're not considering. That is the case in which transaction exchange is not assignable to type never. So what we're missing here is a case in which transaction type is exchange. Here, let me just return a string for now. Let's just return exchange. And voila, this is no longer breaking because we have exhausted every possibility. We have done exhaustive type checking on our code to ensure that we have feature completeness. There is no type of transaction that is not being considered. This is very important because if you want to have a reliable application, you don't want to leave any stone unturned. You don't want to leave anything up to chance. So if you do exhaustive type checking, you're checking every possible scenario and ensuring that everything works as expected. So right now in my application, I should just see exchange in the place of exchange. Let me just very quickly create an exchange transaction item component. So this is going to be exchange transaction item. Then with exchange transaction item, let me type that right there. This is a transaction exchange. Transaction exchange. Here, there is no name. This is an exchange transaction, so exchange. Then we will have, let me place right here, a column and two pieces of text inside, one with the type of value that went out. So this would be from, would be minus, that's right, and 2 would be plus, from would be red, so this is rose, and 2 would be green. Now we have exchange transaction item here. Let's go to transaction item and render that right there. Okay. So just pretend in your minds that this is looking very pretty. This is it. We ensured feature completeness in our application by leveraging the power of never. Now, this doesn't look very pretty. Plus, it would be nice if we could do something else around this pattern. It would be nice if we could, for example, log to a logging service if this ever actually occurs at runtime. So if this code is ever executed on the client's machine, and for some reason we arrive at this point, it would be great to log this. So what I want to do is I want to create a reusable function that I can reuse for any exhaustive type checking scenario that is going to do all of that for me. So I'll call this function unreachable. So Copilot is getting ahead of me right here. I will say that it takes a value of type never and returns never. What it does is it throws an error with a message reading unreachable value set to value. Then what I need to do here is simply call unreachable and pass transaction in. Additionally, here I can call logging service, and I can log to this logging service unreachable value, for example. Then with this, I can keep track of any situation that occurred in which data didn't match what we expected, in which, for some reason, one of the transactions had a different type. This is important because you want to ensure nothing is falling through. So I'll just move this to a separate file. I'll move it to utils, and then we're done with the enrichable function. We can reuse this in multiple places whenever we want. So since we still have about 4 minutes, let me just add something to this. This was the pattern, the main pattern that I wanted to share with you, but there are still some problems with my application. The main problem is I'm loading this data from the API, but I'm casting it as transactions. So I'm trusting that the API is sending me data that is formatted correctly. But imagine a scenario in which it doesn't. Imagine it's missing one important property from one of these. Then if I try to load my application, I hit a runtime error. We don't like that. We don't want that. How can we fix that? So we can fix that by not casting the result as transactions, but then TypeScript assumes the value that JSON resolves with has type of any. We don't want that either. We want it to be an unknown value because we just don't know. We don't want it to be any. So now list transactions returns an unknown value. I'll go to app, and we have this issue here. Transactions data equals unknown, but in fact, we want it to equal the type. We want it to be transactions. So how do we fix this without doing any type casting? We fix this by parsing this data and ensuring that it matches that format. How can we very easily do that? So for that, I'm going to use a third-party NPM package called Zod that is going to allow me to parse this data. So instead of typecasting it, what I'm going to do is I'm going to parse it. So here, I'm just going to request help from Copilot because we need to go very quick. So Zod types or Zod parsers or schemas for types above. Here, this feels like cheating. Okay, yeah. So this is exactly what I want. I want money schema, amount is a number, currency is a string. Then I want this for every single one of them. Is there a way to make GitHub Copilot go faster? Just in case anyone knows. Okay, here it feels like I'm cheating. Perfect. So this is exactly what I wanted. Now, instead of having these types declared manually, I will have these types inferred from those schemas. So infer types from schemas. So that's exactly what I wanted. It's just not right to call this file types anymore. Let's call it parsers. So what I want to do is, in my app component, instead of trusting that transactions data is going to equal an array of transactions, instead, I'm going to initialize this variable called parsed transactions. Parsed transactions equals my transactions schema, and we're going to call the parse method on it, which is going to parse this transactions data. Now, if this transactions data doesn't match this shape, an error is going to be thrown here. If it does, then we have data with the correct shape. We are sure that we have data as we expected. And this is it. We're never going to hit a runtime error again, hopefully, adopting this pattern, ensuring that data enters our app with the correct shape. Then we don't have to do any typecasting inside of our app. We're never going to have to write as something ever again, hopefully. And this just allows us to build a safer and more reliable application altogether. And this is it. This is what I wanted to share with you.
Amazing. Thanks.
Thank you very much.